You find the critical, we find the critical points. We find the critical points. Okay. And for this, we need to find f sub x and f sub y first. F sub x is 3x squared plus 3y, and f sub y هتكون 3x plus 3y squared. And we have two types of critical point. The first type, which is the common zeros of f sub x and f sub y. The points that will make both 0, f sub x and f sub y. So to find this, we have to solve the system, f sub x equal to 0 and f sub y equal to 0. i.e. we have to find the following: 3x squared plus 3y equal to 0 and 3x plus y squared equal to 0. Okay. Here I have a 3 as a common factor. I can divide by 3, you get x squared plus y equal to 0 and x plus y squared equal to 0. So I have a system of two equations into unknowns. The general procedure to solve a system of two equations is really usually we substitute one equation in another equation to get at the end one equation in one unknown. You solve this equation in one unknown and then you do back substitution. The general procedure is really similar to that of Math 1, similar to that of orientation. If I can start with the second equation, this gives me x equals minus y squared. Now substitute this in the first equation. In the first equation, you get x squared هتكون y power 4 plus y equal to 0. So when you substitute x in the first equation, I end up with an equation in one unknown. I solve it using orientation by factoring here. For example, I take y, هتكون y cubed plus 1 equal to 0. I can also factor y cubed plus 1. You get y equals y plus 1, y squared minus y plus 1 equal to 0. Okay. Now this gives me y equal to 0 or y equals minus 1. The last factor here, when you solve it, you get complex roots. And they are rejected. Because we are working with real numbers. X and y are real numbers. X and y are real numbers. So we reject any complex roots. So I have y equal to 0, y equals minus 1. Now I do back substitution. When y equal to 0, y equal to 0, substitute into اللي هي نفسها x equals minus y squared. This is 2. You get x equal to 0. So this gives me a point 0 and 0. This is the first critical point. Second, when y equals minus 1, again substitute in 2. X equals minus 1 squared, which is minus 1. So this gives me a second critical point. So you have these two critical points, and they are both in the domain. So they are critical points of the first type. Okay. Are there critical points of the second type, i.e. f sub x and f sub y? Are there points where f sub x and f sub y do not exist? No. Notice f sub x, it is just a polynomial into variables. F sub y, a polynomial into variable. I can substitute any real number for x and y. So f sub x and f sub y exist for all points. They are exist for all points. Okay. X, y. Okay. So there are no critical points of the second time. There is only a critical point of the first time. We have two critical points. Next, we have to decide or to test what kind of local max or local min or a saddle point these critical points are. And for this, you have to apply the discriminant test. So you need to find f sub x. This is the discriminant. This is the discriminant test, if you remember here. So you just form the discriminant and check the sign of the discriminant at the critical points. Okay. What is f sub xx? What is f sub xx at xy? This is f sub x So when you find f sub xx, you get h 6x, 6, and f sub yy at xy, again to be h sine 6y. When you find the derivative of f sub y with respect to y, you get f y, you get 6y, and f sub xy, you differentiate f sub x with respect to y, you will get just y, 3, you get h 3. So this is 3. Now the discriminant at xy equals f sub xx, f sub yy minus f sub xy squared. When you substitute, you get 6x, 6y minus 3 squared. Okay, so this becomes 36xy minus 9. Okay. This is the discriminant. Now check the sign of the discriminant at the critical point. 0, 0, minus 1, minus 1. So this is 0, 0. This is the first critical point. D at 0, 0. At equal 0 minus 9, which is minus 9, which is negative. If it is negative, what is the conclusion of the discriminant test? If the discriminant is negative, then the function will have a local, will have a saddle point at that point. Okay. So here we have the following: f has a saddle point. Okay. Now at minus 1, minus 1. Again, discriminant minus 1, minus 1. So this is 36 minus 1 times minus 1 minus 9. So it's h 36 minus 9, which is h 27. This is h positive. If the discriminant positive, we have to check a sign, another sign, which is h. If the discriminant is positive, you have to check the sign of f sub xx. If it is positive, هتكون local minimum. If it is negative, it will be h local maximum. Okay. So what is f sub xx? At minus 1, minus 1. So it will be 6 times minus 1, which is h minus 6, which is h negative. Okay. So this implies f has a local max at minus 1, minus 1. Okay. So this is h, how to check or classify the critical points. Okay. Okay, if it is clear, write 1 in the chat. If it is clear, write 1 in the chat. I hope no. But I'm not sure whether you are following me or reading your notes for the quiz. Okay, so just okay. So I will give another example here. Another example. Example 2 of xy equals x plus y squared e minus x, e minus x. Again, the domain solution here, solution, domain, all points x, y in R2. I can substitute any value for x, any real number for y. There will be no problem. So xn minus infinity to infinity and yn minus infinity to infinity. Okay. Critical points. Okay. We need to find f sub x and f sub y. So just I will multiply first. So this is off of xy. This is x e minus x plus y squared e minus x. Now what is f sub x at xy? We differentiate with respect to x. Like x e minus x negative plus e minus x. The product rule for the first term plus with respect to هتكون y squared e minus x for the second term. What about f sub y? F sub y at xy. The derivative of the first term will be 0 because with respect to y. For the second term هيكون 2y e minus x. Okay. This is f sub x and f sub y. Now critical points of the first term, you have to solve the system f sub x equal to 0 and f sub y equal to 0. And this becomes minus x, e minus x, plus e minus x minus y squared, e minus x equal to 0. And this is 2y, e minus x equal to 0. But here I can simplify a little bit, okay, because e minus x is never 0. E minus x is never 0. E power anything is never 0, okay. So I can divide by e minus x in both equations. When you divide by e minus x, you get h minus x plus 1 minus y squared equal to 0, and 2y equal to 0. So this is 1 and this is 2. So you have a system of two equations as usual. Second equation, you get y equal to 0. Substitute in the first equation, you get minus x plus 1 minus 0 equal to 0, and hence equals 1. Okay. So this will give me one critical point, 1 and 0. Okay. So one critical point of first time. Are there points where f sub x and f sub y does not exist? No. Okay. In fact, f sub x and f sub y, notice here I can substitute any real value for x and y. So they always exist. Okay. So هنا exist for all point x, y. So there are no critical points with the second term. So I have one critical point, and it is in the domain also of the function. Well, next step, you use the test, the discriminant test. So test here. You have d at xy equals f sub xx, f sub yy minus f sub xy squared. You compute f sub xx, f sub yy. When you compute them, you get the following. For example, here, f sub xx at xy, you have it there, f sub xx. Differentiate again with respect to x. When you differentiate and simplify, you get the following. X minus 2y, x minus 2 plus y squared, e minus x. Fyy at xy. Differentiate y with respect to y, you got 2e minus x, 2e minus x, 2e minus x. F sub xy, f sub xy at xy. We differentiate f sub x with respect to y, so this becomes 0, this becomes 0. Now when you differentiate this with respect to y, you get minus 2y e minus x, minus 2y e minus x. Now substitute in the discriminant. When you substitute and you simplify, you get the following: 2x minus 4 minus 2y squared e minus 2x minus 2x. Okay. Now check the sign of the discriminant at the critical point 1, 0, d10, d10. It will be h 2 minus 4, هتكون 2 minus 4 minus 0 e minus 2, which is h minus 2 e minus 2. And this is h negative. Okay. So the conclusion, f has a saddle point at 1, 1, 0. Again, just in case if you are not following me, just remember this, and really the general procedure is the same as Math 101. First, we have to find the critical points, then we have to apply the discriminant test. Okay, a matter of checking signs. In other words, in fact, there is no need to give you any example. The procedure is clear, you can do them by yourself. Okay, but in case in case you are following, okay, this is how to find and classify the critical points. Okay, in the notes you have more examples. Please read them. Okay, so this is the first main question in this section. The first main question is find the local maximum and local minimum and saddle points. And the example I gave show you how to find these. Okay. Now we have 2 more questions to be discussed later on. Okay, and this is the first main question. We have 2 more points to be discussed inshallah next class. Okay. So this is the class for today. If you have a question, please you can ask now. If you have a question, do you have any question about what I did today?
Doctor, if the number is positive, it will be maximum, local maximum. If it is 0, it will be minimum.
ايش اللي زيرو؟
يعني إذا طلع لي الجواب بيجي 0
ده
بعد
ده discriminant قصدك ولا لا؟
اي احنا لما نجي نسوي
خلاص هذا التست قدامك هذا التست. اوكي. This is the test. You check the discriminant. If it is positive, I go and check f sub xx and f sub y. You get local max. If the discriminant is negative, it is a saddle point. If the discriminant is 0, no conclusion. We have to use another test or another method. Okay.
راح ناخذ another method.
No, ما في عادة it is left. No. Okay. We say the conclusion is inconclusive. The other methods, maybe you go to the graph itself. If you can graph it, for example, you can see at AB whether it is local maximum or local minimum. Mainly by graph. If the test is inconclusive, then we check the graph if possible also, if possible. But the test is in front of you, just apply it as it is, just checking signs, checking age signs only. Okay.
دكتور ايش معناته saddle point يعني بالضبط؟
It is يعني you can say the following معناته يعني geometrically أو let me say it means إنه if the discriminant is negative, it is neither local maximum nor local minimum. They call it saddle يعني its behavior, it behaves like a saddle of a horse, سرج الحصان يعني. عند سرج الحصان هالنقطة هذه أوكي، هذه النقطة هذه أوكي. It is like this. It is neither local maximum nor local minimum. Okay. من هالقبيل يعني.
تمام دكتور.
So you have a test. You just need to apply the test and that's it. Okay. Okay. So I will continue this section next class, inshallah. Okay. Okay. Now I will stop now for the quiz. Okay. The quiz will start at 10:30 يعني in 9 minutes تقريبا. So during this time please يعني turn on your camera and prepare yourself for the quiz. Okay. Turn on your camera